Hello friends, today we are going to study about chemical kinetics. So what is chemical kinetics? Chemical kinetics tells us when a reaction will be completed or when an equilibrium will be reached. Okay, so it tells us how a reaction will be completed. So rate of reaction depends upon the amount transferred divided by time taken, or we can say rate is equal to dx upon dt, which means the change in the concentration of X at a particular time t. If suppose a reaction consists of reactants A and B giving the product P. So if the reaction is A plus B giving product P, then if rate is proportional to the concentration of A and B, where concentrations of A and B are 1, it means if we double the concentration of A or B, the product will also be double. What it is saying, the rate is directly proportional to the concentration of A and B, where concentrations of A and B are given 1. That means if the concentration of A is 1, so if we double the concentration of A, the product will also be double. Similarly, if suppose rate is directly proportional to the concentrations of A and B, but the concentration of A is 2 and the concentration of B is 1, it means if we double the concentration of A, the product will become 4 times. Next, if rate is directly proportional to the concentrations of A and B, where concentrations are 2 of A and B both, it means if we double the concentration of A or B, the product will become 4 times. So to convert a substrate into a product, if we want this process to be fast enough, either we have to provide energy to reach transition state or we have to lower the activation energy. Let's understand this with a simple example. Suppose there is a point A and one point B. A car is moving and it has to move from A and has to reach up to B. But the road is not straight. The road is having a huge bump in between. Now, if a car is moving from A and it has to reach up to B, it has to cross this bump. So how it can cross the bump? It has to increase its speed. That means it has to give an extra energy. Without giving an extra energy, the car won't climb up this mountain structure. So to climb the structure, the driver has to give more energy to the car so that the car can climb this bump and reach to B. So this is known as this state is the transition state. So to make the reaction fast, we need energy, or if the car want to reach up to B, we have to provide energy to the car so that it can climb up. Otherwise, it won't able to climb up. So we have to provide energy to reach up to this transition state. This is one way. What can be the second way? We have to reconstruct the road and make this bump little lower. In this condition now, as the bump is much lowered now, so the car can easily pass over it and reach the B. So there are two ways how a car can reach from A to B. Similarly, for a substrate to convert into product, there are two ways. Either we have to provide energy so that this transition state is easy to cross, or we have to lower this activation energy. Correct? Because to reach up to the transition state, we are giving energy. That energy is known as activation energy. So either we have to give extra energy so that the substrate can be converted into product, or we have to lower this energy. Earlier it was more energy was required. Now less energy is required. So either we have to lower the activation energy or we have to provide extra energy so that the substrate can reach up to transition state to convert into product. Now, what are the factors that affect a rate of a reaction? First is effect of substrate concentration. Rate is always directly proportional to the substrate concentration. As the substrate concentration increases, the rate of a reaction also increases. For example, if we burn a candle, when we are burning a candle, there are two substrates. One, the wax of the candle, another one is oxygen. So if we increase the amount of oxygen, the candle will burn faster. What is the effect of substrate concentration? As the substrate concentration increases, the rate of reaction will also increase. Next factor is temperature. As we increase the temperature, the rate again will increase. Why? Because more temperature means more kinetic energy. If temperature is more, that means kinetic energy will be more. If kinetic energy is more, means movement will be more. The movement of the substrates will become more. So if the substrates will move more or interact more, then they can convert into product more. For example, if we take two reactant giving a product, so the more these two will interact, the more it will convert into a product. Clear? So when we give more temperature means more kinetic energy. More kinetic energy means more of movement of the molecules. If more movement is there between reacting molecules, that means more they will interact, and when more they will interact, the more they will convert into product. So more the temperature means more kinetic energy, which means more movement of molecules, hence more conversion of substrate into product. The next factor is surface area. Now we already studied about the surface area and its importance. So smaller the size means more surface area to volume ratio. When more surface area, that means more reaction. When more reaction means more conversion of substrate into product. So surface area is also directly proportional to the rate of a reaction, or we can say the rate of a reaction is directly proportional to the surface area. The more the surface area will be, the more will be the rate of reaction. Next is catalyst or enzyme. So what's the function of catalyst? We already learned just now that to convert a substrate into a product, two things have to be done. Either we have to cross the transition state, or we have to lower the activation energy. So catalysts or enzymes help to cross the transition state, or it helps to lower the activation energy. Clear? So these are the factors that affect rate of a reaction. Now, what do you mean by rate determining step? Rate determining step means if there are series of reactions. So rate determining step will be that step that will control the rate of the whole reaction series. For example, if we talk about glycolysis. So in glycolysis, it starts with glucose, ends into pyruvate, right? But this is not a single step reaction. So multiple steps are there in between. Glucose converts into glucose 6-phosphate, glucose 6-phosphate into fructose 6-phosphate, and so on. So in the whole this series of reaction, which step will act as a rate determining step? The step which is slowest. Why? Suppose you are standing in a queue. You are standing at the 10th position. So there are 9 people already standing in front of you. And say for example, 10 more people are standing behind you. So for you to move forward, what is needed? This the person standing on the 9th position should move fast. Suppose 1 reached here, 2 reached here, 3 reached here, but the person standing at the position 9, he is not moving fast. He is moving very slow. So when 1 reached here, 9 is still here. And if you are ordered not to cross anybody, so you can reach up to here only. Doesn't matter 1, 2, 8, wherever they reached. Until 9 move in a speed, you cannot able to move or be in line with 1, 2, 3, etc. And the persons behind you will also become slow because the person standing or walking at the position 9 is moving very slow. So this person is determining the rate of the whole series of reaction. because this is the slowest step. So it doesn't matter the earlier steps are fast or slow. So until the person 9 moves, if you are standing at 10th position, you cannot move. So it doesn't matter 1 is moving in a speed or not, 2 is moving in a speed or not, 3 is moving with a speed or not. Until and unless 9th person move, you cannot move. 9th fellow is determining the rate of your whole queue. Similarly, in a chemical reaction, the rate determining step is the step which is slowest in nature. That will determine the rate of the whole series of reactions. Now, molecularity of a reaction. Molecularity of a reaction means number of molecules reacting in an elementary step. For example, if single molecule of a single reactant is only involved and giving product, it is a monomolecular. If two reactants are involved, each having one molecule giving product, then it will become bimolecular. If three molecules are reacting, it will become termolecular and so on. So molecularity of a reaction means number of molecules reacting in an elementary step. Now what is order of reaction? Order of reaction tells us how the reactant affects the rate of a reaction. First we will see about first order reaction. What is first order reaction? When the rate of reaction depends on the concentration of a single substrate, that reaction is known as first order reaction. So when A is only giving product and if rate depends upon the concentration of A, then it is a first order reaction. So here rate depends upon the concentration of A. Removing the proportionality sign, we have added a constant K. C is the concentration of A and Y negative sign because as the time increases, the concentration of reactant will go down. A is getting converted into P. So as the time passes or as the time increases, the concentration of A will decrease, the concentration of P will increase. So here rate depends upon the concentration of A, which is depleting as the time increases. Hence rate is equal to minus K into C. Rate can be given by dC upon dt, that means change in concentration with change of time is equals to minus K into C. Now what will be the unit of first order reaction then? As the equation says, dC upon dt is equals to minus K into C. K is the rate constant, first order rate constant. So dC, it is concentration, that means in molar. dt, that is time in second. Here also see molar. So molar divided by second into molar is equals to K. This molar and molar will cancel out. 1 upon second is equals to K. So second inverse or second to the power minus 1 is the unit of K. So by seeing the unit, you can able to say whether the reaction is a first order, second order or zero order reaction. Now what is the relation between rate and substrate in case of first order reaction? It is a straight line. That means as the substrate increases, the rate of the reaction will also increase. What's the relation between concentration and time? As the time increases, the concentration of A will decrease. T half means the time at which half of the concentration of the reactant converted into product, which is given by the formula T half equals to 0.693 upon K. If we want a straight line plot for concentration and time, then we have to plot between time and natural log of concentration of A. What is second order reaction? In second order reaction, as the substrate concentration doubles, the reaction rate becomes 4 times. That means the rate of reaction depends upon the concentration of reactant, where the concentration of reactant is 2, or we can say 2 molecules of reactant are participating. So either it can be a single type of reactant or it can be a two different variety of reactant. So either it can be identical or non-identical reactant. So in second order reaction, the rate depends upon the concentration of reactant, where the concentration of reactant is taken as 2 or the molecularity is 2. That means 2 molecules are interacting. So case 1, if the reactants are identical, so here we can see A plus A is giving product. So rate depends upon the concentration of A, because two molecules are participating, so square. So here rate is proportional to minus C square, minus because as the time increases, the concentration of reactant will decrease. So rate is equals to minus K into C square. Rate is dC upon dt is equals to minus K into C square. If the reactants are of two different types, that is A plus B is giving product, so rate will depend upon the concentration of A as well as on the concentration of B. Here one molecule of reactant A and one molecule of reactant B are participating, giving overall of two molecules. So here rate is proportional to C into C and the same, minus C square. What is the unit of second order rate constant? So the formula is dC upon dt is equals to minus K into C square. K here is second order rate constant. So dC molar dt second equals to K into C square means molar square. This molar square here will come down. So molar divided by second into molar square. This molar and this molar will cancel out. One molar will remain. So 1 upon second into molar is the unit of K. So we can write molar to the power minus 1, second to the power minus 1 equals to K. Or if we want to write in the form of moles, so molar is equals to mole per liter. So we can also write in the form of mole per liter. What is the relation between concentration and time? So as the time increases, here also the concentration of the substrate will go on decreases. How we can get the straight line plot? So to get a straight line plot, we have to plot between time and 1 upon concentration of A. For these things, no need to go in a deep that why this is coming and how this is coming. Just you have to remember that what are the conditions when you can get a straight line plot between time and concentration of the reactant. So the zero order reaction means the reaction in which the rate does not depend upon the concentration of the reactant. So if two reactants are present, A and B giving a product B, the rate will be equal to K because here rate does not depend upon the concentration of A or B. What will be the unit of zero order reaction then? C divided by dt equals to K, molar divided by second equals to K. Molar for concentration, unit of concentration, second is the unit of time. If we plot velocity versus substrate, so we'll get a horizontal straight line. Why? Because here the rate of reaction does not depend upon the concentration of the substrate. So increase or decrease in the concentration of the substrate won't affect the rate of reaction. Hence we can get a straight horizontal line. So if we plot between concentration and time, then here we'll get a slope, the value of rate constant from this slope. In which situation we can get a zero order reaction? When the concentration of substrate is very high. If the concentration of substrate is very high, in that situation, if we increase or decrease the concentration, it won't affect the rate of a reaction because it is already too high. So when it is too high, say for example, if in a class 1,000 students are present, from that class, if I decrease the number of students by 2 or if I increase the number of students by 2, it won't affect the class as such. But if the class consists of only one student or two students, in that case, if I decrease the number of students by 2, the class will get affected because only two students are present over there. And if both are not there, then no one is there in the class. So class will get affected if we increase or decrease the number. If only one or two students are present, in that case, if we decrease the number also, the class will get affected. If I increase the number also, the class will get affected. But if there are already 1,000 students are studying in a class, in that class, if I add two students or if I remove two students from that group, it won't affect the whole class. So when the substrate concentration is very high, in that situation, the rate of reaction do not depend upon the substrate concentration. Now, one more reaction is there, which is known as enzyme catalyzed reaction. And how the graph of an enzyme catalyzed reaction look like? So the graph can be divided into three parts, A, B, and C. This is increase in substrate concentration. This is rate of reaction. This part is like this part. That means the part C follows a zero order reaction, because substrate concentration are increasing and it reached to a point when the concentration is very high. A part, when the substrate concentration is low, in that situation when it is increasing, it affects the rate of reaction like a first order reaction. What about part B? This part B is not resembling exactly to any order reaction. So this comes under mixed order reaction. Greater than A, lesser than C. So in case of enzyme catalyzed reaction, we can be able to see first order reaction also, mixed order reaction also, and zero order reactions. So clear? Understood? What do you mean by order of reaction? And what is the difference between first order, second order, or zero order reaction? So by seeing the unit, also you can able to say whether the reaction is a first order, second order, or a zero order reaction. You have to look for the unit of K. By looking for the unit of K, you can able to say which order reaction it is. One question from my end for you all. Do write in the comment section that if you dissolve sugar in water, which form of sugar will dissolve faster and why? Is it powdered form or crystal form? Here you have to give the answer which form will dissolve faster and why that form will dissolve faster. Powdered form means small size, crystal form means bigger size. So do write me in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.